You know, making all these videos is pretty exhausting work. What I need is a vacation. Somewhere far away, preferably exotic, and must be exciting. Korea or maybe Japan. Great food, fantastic culture, plenty of ways to embarrass myself by misunderstanding the local customs. What's not to love? But I noticed something strange while booking my Asian getaway. My plane seems to be making a detour over Alaska. Why is my plane going out of its way to avoid the Pacific Ocean? Is this a mistake? Did I accidentally sign up for the Caribou route? At first, you might think this was a safety issue. The Pacific is the largest and deepest of the world's oceans. If a plane encounters a problem over a seemingly endless and bottomless pond of water, the pilots are going to have a rough time finding a safe spot to set her down. Alaska might not be overpopulated with international airports, but it's a lot better than the middle of the ocean. How's that for a tourism slogan? Alaska. At least it's better than sinking. Okay, I apologize, Alaska. Guessing that it was a safety precaution wouldn't be entirely wrong. When planning a route, many pilots prefer to maximize the number of airports along their path. Emergencies are incredibly rare relative to how many planes take to the skies every day. But I can't think of many things more stressful than losing an engine 30,000 feet over the middle of the Pacific Ocean. That said, it isn't the main reason airlines tend to avoid making a straight shot east to west. Ultimately, it comes down to saving fuel and time. It's easy to forget that an airline is a business whose profits depend on how quickly and cheaply it can move passengers between destinations. People also prefer to get to their next stop as quickly as possible, so it's a win-win for both airlines and passengers. Long story short, which is not my forte, speed is usually the primary factor in determining a plane's flight path. Excluding special circumstances such as passing through the jet streams or other meteorological concerns, the fastest route is almost always the one closest to a straight line. But wait, just look at that flight path. It's anything but a straight line. Well, yeah, when you look at it on a flat map. But our planet isn't flat now, is it? It can be confusing since we're used to looking at our world on a two-dimensional plane. Unless you bust out a globe each time you need to check where some city or country is located, you probably look at a world map. So, on a 2D map, making a giant rainbow to avoid the Pacific Ocean looks like a much longer route. But since the Earth is a sphere, more or less, but more on that later, a straight line is going to look very different in three-dimensional spaces. Okay, let's do a little experiment. Got a globe nearby? Oh yeah, I just said most of us use Google Maps. Alright, here. I'll show you on mine. I put one end of a string on Los Angeles and the other end on Tokyo. When I pull it tight, you'll notice that the string isn't running exactly parallel to the lines of latitude printed on the globe. Instead, it'll bend slightly upwards as it follows the curvature of this mini Earth I got at the bookstore down the road. This effect is even more pronounced in practice because my globe isn't a perfect recreation of the real deal. In fact, the problem is that it's too perfect. You see, unlike a globe, the Earth isn't a perfect sphere. Our planet is slightly bigger around the middle, kinda like me after the holidays. Wait, who wrote that? When looking at pictures taken from outer space, the difference isn't enough to notice. The planet is so big that it's easy to lose track of a few hundred miles here and there. But check it out. If you could take a giant string and measure the Earth's circumference through the poles, you'd need 24,860 miles of string. But if you do the same at the equator, it would jump to 24,900 miles. Why is that, you ask? Well, it's because our planet rotates on its axis. Ever spin yourself really fast on the playground merry-go-round when you were a kid? Remember feeling like the thing was going to throw you out to the sides? Actually, I remember I was throwing up a lot. Not a good ride for me. Anyway, something similar happens to the Earth's midsection as it spins. The force causes it to bulge out. Yes, it's spinning fast enough to do that. Anybody tuning in from the equator right now, you're currently moving about 1,000 miles per hour. That 40-mile difference in the Earth's width might not seem like very much, but when it comes to the surface area of an entire planet, that little bit of added girth can go a long way. The combination of these two factors, the curvature of the Earth and its extra equatorial width, I like that, mean that curving toward the poles is a shorter distance than flying, what seems like on a map, straight across. None of this is to say that planes never cross the Pacific Ocean. People have to get to Australia somehow, I guess. I'm not so much into giant insects and spiders, but hey, to each his own. Just kidding, Australia. Anyway, planes will also venture over open water to avoid storms. While aircraft can outclimb some types of severe weather such as hurricanes and tropical storms, seemingly mundane thunderstorms are surprisingly challenging. With clouds reaching altitudes of over 60,000 feet, airplanes are advised to steer around instead of into or over them. It's almost unheard of for modern aircraft to be brought down by severe weather. But bad enough turbulence can cause injuries to passengers and crew if they, and all the stuff they've packed with them, get tossed around the cabin. The takeaway here is keep your seatbelts fastened at all times. Another reason planes will sometimes brave an oceanic voyage is to take advantage of the smoother ride. Even in clear weather, there's much less turbulence over water than over land. This is because the primary source of turbulence is hot air rising up from the ground. Hey, there's a lot of hot air rising up from this microphone. Water distributes heat a lot better than soil, so flights over the ocean are often much smoother. The other primary consideration for determining flight paths are air currents, namely the jet streams. These high-altitude air currents exist near the top of the troposphere. That's the lowest layer of the Earth's atmosphere, and the one where most weather occurs. The border between the troposphere and the next layer up, the stratosphere, is known as the tropopause. Its altitude fluctuates between 4 and 12 miles above the Earth's surface. This fluctuation results in rapid shifts in air temperature and pressure, which creates a wind tunnel that can reach speeds of over 200 miles per hour. These extreme speeds are most common in winter, when the temperature difference is greatest, but regular wind speeds of 80 to 140 miles per hour are nothing to scoff at, so keep your scoffing to yourself. There are 4 main jet streams, 2 in each hemisphere, and thanks to the Earth's rotation, they mostly flow west to east. The 2 most important for air travel are the polar jet stream, which forms near the Arctic Circle, and the subtropical jet stream near the equator. Both are thousands of miles long despite being only a few miles wide. Flying with a jet stream can shave several hours off of a trip, but flying into it can slow the plane down considerably. It's also worth noting the risks associated with jet streams. The biggest hazard is a kind of turbulence known as clear air turbulence, which occurs along the edges of the streams. This kind of turbulence is nearly impossible to predict and far more intense than the usual variety. Turbulence-related accidents are rare, but they are possible. One particular serious incident happened in 1997, when a plane flying from Tokyo to Honolulu suddenly dropped after hitting a patch of clear air turbulence. The pilots were able to regain control, but many passengers had been thrown from their seats really hard by the sudden descent. With that danger in mind, flight plans need to be carefully calculated to take advantage of the jet streams without putting the plane at risk. Repeat after me, keep your seatbelts on at all times while flying. Understanding why planes take the routes they do often comes down to facts that we don't usually think about in everyday life. The jet stream mostly affects things tens of thousands of feet in the air, and the curvature of the Earth doesn't really matter unless you're traveling hundreds of miles per hour over vast distances. I don't know about you, but my car can't quite manage either of those things. At least not yet. I have a few ideas, but we'll save that for a video titled 7 Things You Shouldn't Strap Rockets To. Hey, if you learned something new today, then give this video a like and share it with a friend. And here are some other cool videos I think you'll enjoy. Just click to the left or right. And remember, stay on the bright side of life.